In our last lesson, we discussed slope and how we would find the different ways to get slope, whether it be rise over run or the change in the y values over the change in the x values. Now, we're going to move into this next lesson where we're actually going to graph linear functions. And so if we have an equation in the form of y equals mx plus b, that's what we've learned in Algebra 1 as slope-intercept form. And the reason it's slope-intercept form is because the two main parts of the equation give us the slope of the line and give us the y-intercept, the place where the graph will actually cross the y-axis. So it's very important that you understand what an intercept is. In this case, more specifically, the y-intercept. Now, for this particular situation with slope, we're going to have to know it as rise over run. And so if we're in a situation where we're given a slope, we know it to be rise over run, and this will allow us to count from point to point and get multiple points. Now, the section title is Quick Graphs of Linear Equations. Now, if you recall, we discussed in an earlier unit that the bailout for any function, to graph any function, would just be simply to create an XYT chart. So you could plot as many points as you wanted by taking x values and plugging it into the equation and getting the corresponding y value. Now, that is always an option here, but what we're trying to do in this particular lesson is to give you some options to actually graph these things a little quicker. So graphing lines should be an easy process, and we're hoping that you're able to do this a little bit faster. So let's take a quick look at the steps involved of graphing slope-intercept form. First things first, no matter what form we get the equation in, we need to write it in slope-intercept form. So you can see in the steps here, that's the first step. Then we need a starting place. So the starting place is always going to be our y-intercept. And keep in mind that our y-intercept is always written as 0 and then whatever the number that is representing b. So it is the place where it crosses the y-axis. So that's our first point that we need to plot. From there, we can count the slope, we can count the rise and then over on the run and create a second point. And then we can use the slope again to count and even create a third point. Once a third point is created, you have a definite pattern for the line, and you can simply draw the line through the given points. So if we come down here, we look at an example, you can see that we're following these points. And so we have -2, so that is going to create the point 0, -2 as our y-intercept. So that should be the very first thing that is plotted, and you can see that that's done right here on the graph. Then we identify the slope, and so it doesn't matter what we count first. If we count the rise up first and then over for the run, or the run first and then the rise, we're going to end up having a second point. Now, you only need 2 points to define a line, so this would be plenty enough to go ahead and draw the line. If you felt more comfortable counting a third point from slope, that would work just as well. So then you would simply draw the line through the given points. So let's take a look at sample problem 1. We have part A and we have part B. So I'm going to ask you to quickly pause the video and try to draw the line for these two graphs. Please use a straight edge, as it'll make your lines a lot better. Let's take a look at the first one. Part A is pretty straightforward. We have a intercept, a y-intercept of 0, 1. So I'm going to plot that first. So I'm going to go 0 and then 1. So that's kind of my starting place to start counting slope from. Very important that you always count your slope from an actual point on the graph, and the quickest and easiest point we can find is the y-intercept. And then the slope is 1/2, so that's rise over run. So I'm going to go up 1 and over 2. I could also reverse that process and go down 1 and backwards 2, and of course -1 over -2 is going to equal 1/2. And from there, and I don't have a straight edge handy, but you could basically see the trend through those 3 points, and we would draw the line. And that represents the line of y equals 1/2 x plus 1. So if you're looking at a translation from the original parent function, and if you recall, the original parent function would be simply on that diagonal line. What's happened here is I've actually shifted over shifted up 1 from the origin, and then I've kind of flattened out a little bit because of that 1/2 slope. So it actually follows the transformation rules that we've learned in a previous unit. But that would take a little bit extra, so following these quick graphing rules would actually work better, I think, for you. Alright, let's take a look at part B. Very first thing that we have to do is we actually have to rewrite this equation. So now I have 0, -1 as an intercept. So I'm going to graph 0, -1, and then the slope is 2/3, so that's rise over run, so that's 1, 2 over, up, 3 over. I could also go down 2 and backwards 3, and notice it's a positive slope, so I know the line should be going up from left to right. Now, I did a terrible job of drawing that through the 3 points, but hopefully you're using a straight edge to do this correctly. So that's a quick introduction to graphing lines in slope-intercept form, so hopefully you learned that very well in Algebra 1, and that was just a quick review.